Feedback Circuit Analysis Part 2. With a new amplifier circuit represented by proper model, we can proceed to evaluate the amplifier gain, A' of the A' circuit. From the circuit, we can see that the amplifier gain, A', is equals to V out over Vs. V out over Vs can also be represented by two equations on the input side and output side of the A' circuit respectively. They are 1. Vin over Vs, 2. V out over Vin. Therefore, to evaluate the value of A', the gain of the A' circuit, we need to first evaluate these two equations. First, let's derive the equations of Vin over Vs based on the input side of the A' circuit. To aid in our circuit analysis, we can first redraw the input side of the A' circuit. Next, we can convert the voltage source and resistance of the redrawn circuit highlighted in green to a Thevenin's equivalent source and resistance. To get the Thevenin's equivalent source, we simply apply voltage divider rule. To get the equivalent resistance, first short the voltage source Vs, and by visual inspection we can get the equivalent resistance. From the new circuit, we can apply voltage divider rule to obtain the equation of Vin. With some manipulation, we have successfully derived the equations of Vin over Vs based on the input side of the A' circuit. Now, let's derive the equations of V out over Vin based on the output side of the A' circuit. We can apply voltage divider rule to obtain the equation of V out. With some manipulation, we have successfully derived the equations of V out over Vin based on the output side of the A' circuit. Up till now, we have managed to derive the two equations on the input side and output side of the A' circuit respectively. To get the equation of V out over Vs, the gain of the A' circuit, we simply multiply the two equations we derived earlier together. We can also derive the equations for the input resistance and output resistance easily, based on the circuits of the input and output side of the A' circuit as shown. With all the equations derived so far, we will be able to find the new closed-loop gain AF, input resistance RIF, as well as output resistance ROF of the feedback amplifier.